want to talk to you guys about in terms of specific heat is taking a look at our beach scene. So if you see that our initial temperatures were 23 degrees and 20 degrees Celsius, and then after 30 minutes of our fake sun being at the beach, the sand went up to 28 degrees Celsius, which was a 5-degree increase, while the water had a 4-degree increase up to 24 degrees Celsius. But then after just 10 minutes of the sun being down, okay, of having the sun be up, the sand had already dropped 2 degrees, okay, but the water had only dropped 1 degree. Between the sand and the water, which one has the higher specific heat capacity? Water. Water has a ridiculously high specific heat capacity, and it's what makes it work on the planet so well. It's also what makes climate change so scary for scientists, because when we say that the ocean water has increased by 1 degree on average over the whole planet, that is a huge change in global air temperature and all sorts of other temperatures, because it takes a lot of energy to be able to change water by even just 1 degree. It takes tons of joules of energy, okay? Whereas with sand, it doesn't take as much energy to change its temperature because it has a lower specific heat capacity. This is also why at the beach in the summer, you can walk on the sand and burn your little feet, and then you go in the water, and the water can still feel quite cool, right? And it's also why if you were ever to be brave enough to go to the beach in the winter, the water may only have dropped maybe 10 or 15 degrees, which is just enough to give you hypothermia if you go swimming. But the air temperature and the sand temperature could have dropped 30 or 40 degrees in that same amount of time. Okay, so being at the beach is a really great example of our specific heat capacity and how water has an incredibly high specific heat capacity. And that actually affects our weather systems. It's why at the beach you often see clouds just out over the water, because you've got your nice heat, okay, and it's cooling off over the water when it heats up on the sand, and then it cools off as that air circulates over the water in its circle. All right? That's the convection currents. Are there any questions about this? All right, thank you. Oh!